Yeah, I can. Hello, everyone. Welcome to Web Hacking 1. Today, we are going to be covering the very basics of web security, which is we're not going to be talking about security that much. We're going to be talking about fundamentals of the web, how websites are structured, and how they work.
Perfect. So yeah, I can do that. So first off, I want one big announcement. And I want to say thank you guys for showing up. I appreciate you guys showing up. And I want you to ask more questions. I think that everyone in here has, like, the people on the SIGPwny team, the admin team, the helper team, have all put a lot of effort into trying to make the content easier to kind of take in and understand. And we really, really, really love when you guys ask questions. So I'm begging you guys to ask questions throughout this entire meeting. You have questions, raise your hand, we can answer them. We love when you guys ask questions. And I'll be bugging you guys and walking around like asking, oh, you need any help? But feel free to ask questions. We want to make it an open space, and we're only as good as the questions that you guys have. So with that, we also have Fall CTF. Fall CTF is our event, happens in the fall, and September 21st. And it's a great opportunity to come out to not only practice CTFs, but also get internship opportunities, as well as free pizza. So come out. And with that, drum roll. Oh, actually, no, never mind. I guess it says my bad.
Yeah, so we didn't go over this last time because Pony CTF was down because some servers were down when we did our setup meeting. But I will briefly show you guys. If you go to ctf.sigpwny.com, hold on. There is this is what the site looks like, and if you click on challenges at the top, you can see all the current challenges that we've put up on the page. And the Web 1 meeting here, you can find, we'll have a meeting flag. And you can type in a meeting flag from the slides. And the slides are also published on the website. If you're not there, this one will be uploaded very soon. And then we have these challenges at the end of the meeting for you guys to attempt and basically solve. And we have going all the way up to sort of these medium level challenges. But yeah, so make sure to go to ctf.sigpwny.com, make an account, and put that in as your flag. And you'll get some free points, basically.
They have to include the SIGPwny, right?
Yes, you will have to put this little SIGPwny and then the curly braces around the flag here. But as if you guys come to our CTF meetings, when we play CTF, there will be you'll see flags in the same format where you have some sort of common identifier and then curly braces and some unique string.
Yeah, so whenever we participate in CTFs, they're similar to this format. Yeah, so they would look something along these lines. So
all right, we're going to move on now, and we can the slides will be shown at the end again, but they're also online now. So brief table of contents, where we're going to go over how websites work, the bones, skins, and brains of the internet, how it works in terms of the client and server model, and then we're also going to go over some tools that you can use to figure out what's going on. So,
I know. So yeah, so how websites work. Who here has set up a website? I guess I have to. Raise your hands higher, honestly. Okay, so we have a few people who kind of may have some experience with websites, and that's exciting. And other people who don't have as much experience, like, is a great opportunity. So websites are built off of three main languages. But I also want to kind of contextualize this because this is a very, very, very fundamental view of websites. If you look online how to make a website right now, you'll probably get a result of a framework, or you'll see React, or you'll see all these words about like CI/CD pipelines and all these other different things. You need to kind of take a step back from a lot of the modern development that's happened with websites recently. And almost thinking like the 1990s, like computers just started becoming a thing, the internet just started becoming a thing. You want to make a website? This is the bare minimum. And so the three things that we have on the website are HTML, which are kind of like the bones, CSS, which kind of like makes it like look cute, like that, and then JavaScript, which allows you to kind of have logic. And we kind of go into that. So HTML, think of it as the bones. Here's an example of this. So this is, I don't know, what's the name of this website? Like Hello World, maybe like Hello Cat. But it has an HTML brace and a paragraph. So one of the things about the elements in HTML, which we have like a paragraph element, an image element, script element, is that they have an open and then they have a close. And in between, on a paragraph element, you'll have something like text or a paragraph. Then you have the image. The image can be really any type of file path to a file within your directory. So for this example, you have the HTML file, but you also have the cat.jpg in that same folder, as well as the scripting. So there are a bunch of different words or like key terms, like the paragraph, image, script term. But overall, HTML is kind of just holding all of the raw information about your site, and it's going to structure your site. And then as we kind of go a little bit further away from structure, we have CSS. And CSS is, it like makes it look cute. Like now, like it'd be called like cute cat site or something like that. And it adds information. This will effectively create a different kind of aesthetic on your site. A lot of modern frameworks, like for example, like they kind of abstract out CSS. So there are things like the component library and framework for Tailwind that you may see. But right now we're focusing on the very basics, which is just raw CSS. And then JavaScript. So who here has experience with JavaScript? Okay. Who here's taking 124? I know one person is. Okay, good. Raise your hand a little high for 124. Who's taking Java from 124? Okay. So why are they named similar? Right? Like that's kind of the question that I first had, right? Oh, if you want to answer, yeah, go ahead.
Okay, so basically what happened was, JavaScript was created by Sun Microsystems, is that correct?
I think Netscape.
Oh, Netscape, yeah. But then they were trying to ride the hype of Java, because Java was the big thing back in the day. Yeah, so they were trying to ride the hype of Java, and they went through a couple of naming things in the beginning, like copy script or something. And then Oracle, and then eventually it was bought by Sun Microsystems. And then Sun Microsystems was bought by Oracle. And then Oracle has the JavaScript name and it has literally done nothing with it. So anytime you try to look up anything to do with JavaScript, if it's something official, it'll be called ECMAScript instead, because, and there's a lawsuit going on right now with Oracle. But yeah, that's the bare bones of the history of JavaScript.
Yeah. Yeah, so that's a perfect example. And anyway, for the people in the back that may not have been able to hear, effectively what happened was early times, like it was like the early 90s, like the 90s. C++ was really big. Java came out as a new programming language. It was like, okay, C++ without pointers. You don't have to think about memory, we have garbage collection now. It's really new. Java was awesome. Everyone started using it. And that's why kind of if you go to a company that, or if you intern at a company that uses like more legacy, like older technology, they may or may not be using Java because of this, because it was so popular in 2000. Then after this, JavaScript kind of tried to ride that hype, and now JavaScript exists, and it is not Java. So if you're taking 124 and you're taking Java, JavaScript is entirely separate. Still logic, it's still like has logic and things like that, but they're different languages, and JavaScript specifically is made for logic in browsers and websites. And then they decided to try and put it in every single other thing. So this is an example of JavaScript. Is anyone familiar with the DOM? That's another big thing to talk on. I guess you want to, yeah, you're familiar with the DOM? Perfect. Do you want to give an explanation of the DOM? Okay, perfect. I guess I can give an explanation. And I'm gonna keep it pretty high level, but really the DOM is what JavaScript interacts with in order to change things or kind of make the website interact. So in this example, document.getElement by ID cat is effectively using the DOM, which is like the document object manager, to interact with the website. So in this scenario, when you click on the cat, it meows. And I think that's how cats work in real life. They just don't tell you that. It's kind of like the whole birds or robots thing. But yeah. And do you have anything else to say about JavaScript?
So JavaScript is a very interesting language in that there are many cores with it. You'll see kind of these memes when you learn different programming languages, comparing different syntaxes with JavaScript and how it will do really weird things. There's like a whole like site that's dedicated to finding weird things with JavaScript. You may have also heard of JavaScript sort of minor improvements such as successor TypeScript. So that was created by Microsoft to try to fix a lot of the problems with JavaScript. If you guys know, TypeScript actually just compiles down into JavaScript. So the only thing that TypeScript is really useful for is helping you write good JavaScript. And then it just compiles down into JavaScript.
That is actually a really good call out of the difference between TypeScript and JavaScript. So let's continue. Perfect. And then pretty much we want to talk about how the web works and what the client server model really looks like. So this is your browser. This is your browser. This is your computer that you're on right now. When you log on to a website, think like example.com. Or is that on the slider in the future?
It's a town.
Example.com. You send at a very high level, like there is a lot of stuff going on here. There is a hypertext transfer protocol, there's SSL encryption, there's an IP address, the domain name system. High level, you send this string to a computer. A server is just a computer, and usually servers are always on, or they try to always be. You send this information to a computer, which is just a string. Think kind of like we talked about the file system in the terminal last meeting. Think like this is just a path in the computer. This is kind of just a location for a file that's supposed to be there. Right now, index.html is supposed to be in the server. And then the server just gives you that file. At a high level, this is how an internet request for a website or a web page would work. And that's effectively the client server model. And we say it's the client server model because there are other models as well. I don't know if we ever talk on peer-to-peer networks in this class. Do we? Or in this like in SIGPwny? Do we talk on peer-to-peer networks at all? Right?
We might touch on it in a networking meeting.
Yeah. Okay. Yeah, that makes sense. So there are other models, peer-to-peer networks being one of them. If you want to look at it or talk to anybody about it, feel free to reach out and ask. But specifically for this scenario, this is client server, meaning client being your computer reaches out to a server that's always on, like google.com or any type of website, and receives a web page. And so specifically in our example with the like cute cat website, we requested the main components of the page, but we don't just send one request. Because we have information like the cat picture, or we also have information about the scripting file, we have to make multiple requests. And so for that one website, we don't actually make just one request, but we request multiple times. And so that's kind of what this visualization is showing. We request the cat photo, and then we also request our script file. And yeah, and now I would love to hand it off to the great Minh to talk about cookies and hosts. Give him a hand.
Thank you. Thank you, Julius. So I'm sure you guys have clicked on a little banner that says acceptable cookies or denial cookies. Cookies are used to store information about you when you visit the site. The most useful features for cookies is sort of maintaining client-side information. So that way, like you can store like a token, so that way you can re-log into a website without having to enter your username and password again, because that would get very annoying fast. There's a few different ways that cookies can do authentication. So one of the ways is with session-based authentication. So whenever you visit a website, the server will generate a session ID, and then it will give you the session ID as a cookie. And on the server is sort of storing information about you that is tied to that session ID. So the only thing that you need to log into the site or access to that information is your session ID. If your session ID changes, the server can't look up that information that corresponds with that session ID, so it will create a new session. And there are some other alternative methods of authentication, which we'll talk about in the future, such as JWT authentication, which is JSON Web Tokens, and that uses pure client-side math and cryptography in order to avoid storing state on the server side. And we'll talk about what that means in Web Hacking 2, where we talk a little bit more about the server side of web security.
I have a question for you, Min.
Yeah.
Are cookies like, is it easy to just, have your privacy with cookies, or like, are cookies kind of complicated to work with when it comes to privacy and data protection?
Yeah, so that's a very good question, Julius, and I think you guys already know the answer, that because cookies can store unique information about you, they're very heavily used by advertisers in order to see what sites you visited, and also sort of track where you're going, and that way advertisers can better advertise products to you. So there's privacy implications with cookies. Most browsers nowadays block third-party cookies. So when you're on a site, usually cookies from third-party domains are blocked. However, if the first party is working in cahoots with the advertiser, it's kind of moot. So we'll talk a little bit more about privacy and that type of subject in the future. But we'll be focusing on cookies in terms of security, which is for things like authentication. Does anyone have any questions about cookies?
So when I just mindlessly click the banner that says accept all cookies, really be doing that? Or is there like a case to be like, no, actually you should hit no, and here's why?
So it's really up to you. I can't say whether to accept or deny all cookies. Some might be useful, like essential cookies. They'll call essential cookies as the ones that log you into the site. Usually when you click accept all, you're also accepting optional third-party cookies, which also allow the ability for advertising and tracking. If you don't want to see personalized ads, you can click deny all. If you like being sold to, you can click accept all. That works too. But a lot of times, they're like, for website developers, they're not trying to invade your privacy in that sense. Sometimes they just want better analytics. So they'll have cookies which load the page and can run some code, which will see like what buttons you click on, or what area of the page you spend more time in. And this lets them sort of like look at statistics and better optimize their site as well. So sometimes it's not necessarily from an advertising point of view, it's just maybe improving usability of the site. But yeah, does that sort of answer your question?
Yeah. I have one other thing to also add on that. And a lot of times you can actually personalize, like you can, if you read through some of them, like sometimes you can actually like disable cookies for marketing. Or like only keep the essential cookies. Like they'll give you like 3 options, and like the one that they want you to click will be highlighted, but then like the other ones won't. So if you just look through them, usually I'll just like click the essential ones and.
Any other questions?
Is there legislation around the labeling of cookies? So like, what if they say it's an essential cookie, but it's really not?
So, that itself is not regulated as well, and there's not a lot of case, studies or like
Case law.
case law, surrounding that topic. Even the subject of what the cookie prompt looks like. Like if I have accept all and deny all, or maybe I highlight and make the accept all button bigger than the deny all, or maybe I don't have a deny button, and I hide more options. And now I get to click more options and then turn everything off. So that itself is also a legal gray area. And yeah, so it's kind of whatever.
Good question.
Okay. So let's see cookies in action. So here, the browser makes a request to index.html. The server responds with a page. And with this page, the server also sends a cookie. And tells the browser basically, hey, set this cookie for your user on behalf of the server. And so the next time the browser visits the page, and it visits specifically, for example, .com, it will also send a cookie for that server. Additionally, with cookies, cookies are not the only way to store state on the client browser. You could have local/session storage. So local storage is a little bit of a interesting concept because it's sort of like a local file system. It's like a temporary file system that's linked to a website. You can only interact with the local storage using JavaScript. With cookies, those are handled automatically by your browser, and usually you don't even want JavaScript to be able to access cookies. And we'll talk a little bit more about why you don't want JavaScript to be able to access cookies in web hacking too. But if you do have some JavaScript code that needs to access or store local state, you would be using this local/storage session. And so you can see here we have like an item, which is the key value sig, and then we actually want to store the value pony. And so when we want to get the item with the name sig, it's going to return pony. And the same concept with session storage as well. And so session storage is a little bit more ephemeral. It will clear when the browser gets close.
Yeah, so don't cookies technically come under, if I remember correctly, when I actually studied these before, cookies can be stored as both local as well as session storage, right?
So cookies are actually stored in a separate database from local and session storage. You can have what is effectively a cookie stored in local or session storage. You can implement the exact same thing that cookies are, but cookies have their own database. And the reason for this is related to cookie security. When I visit google.com and I sign in with my google.com account, I'm going to get a cookie from google.com with my credentials. If somebody gets that cookie, they're going to be able to log in with my Google account, which is really bad, right? So how does the browser know, like if I visit attacker.com, not to send my cookie for google.com? And the way it does that is it looks at the host name of the cookie. So the browser does sort of this smart management of cookies in the background, which is why it's a separate process from local and storage state. And if you wanted to have cookie security in your local storage, if you put cookies in your local storage, you have to be very careful because you're taking the cookies into basically your own hands and you're managing the security of that yourself.
I get that. My question was a little bit more along the lines of, functionally speaking, cookies do have an equivalent of a local as well as a session store, right?
Yeah, exactly.
What are general things stored in local and session storage? Like, what is website storage there?
So one thing is very popular for local storage is sort of caching. So let's say, let's say I have a website application which shows courses on campus. Now normally the courses for university don't change that often. And maybe like, let's say I have a lot of courses with a lot of information about them. Or maybe I'm like downloading photos. Actually, let's switch this. Let's say I have a photos web app and I have a lot of photos. When I first load the page, what it's going to do is it's going to make a lot of requests to the servers for photos. And every time I reload the page or visit the page again, it's going to keep making all those load image requests, which can be a big burden on the server. So I could cache images in the local storage, so that way I don't have to make those requests every time. And the browser already has caching in place. So you can basically store sort of more application-specific state, which is dependent on what your application needs to store on the client side. Yeah.
Just to follow, where in my computer is this local storage stored or where in my browser?
Right. So we'll actually go about that in the next few slides. It's one you can find on your dev tools. In terms of your computer, you're going to store it in sort of like a database file in your browser's files. Any other questions about local / system storage? Okay. So now we're going to go over some important tools which will help you analyze websites. So maybe at some point, maybe in like elementary school, you discovered the power of inspect element, and you could, change Wikipedia to say funny things. Yeah, you can basically open DevTools by basically doing Control-Shift-I, or if you click the little 3 dots in your browser and probably go down to more tools, you can open up developer tools. And it'll open up a little panel on the side or at the bottom of the page, which shows basically the source code of the website. Not the source code on the server side, but the code that the server sends to you as a client. So here you can see if you click the Elements tab, you'll be able to see the HTML and the structure of the page. You can also quickly access on most sites the DevTools by right-clicking an element and then clicking Inspect. If the page hijacks your right-click, then you have to use Developer Tools shortcut. But otherwise, there's a few ways to get to DevTools.
I have one note on this as well. If you're on Mac, you may not have developer tools like enabled effectively, and I think you have to go through and like, I think there's an extra process that may be hidden to like the front end. I don't have a Mac, but I think you have to like enable them.
Yeah, I think that's specific for Safari.
Oh,
yeah, if you're using Chrome, DevTools will be here. You use Edge or Brave or any Chromium-based browser. They all are based on Chromium, which use the same DevTools. Firefox has its own version of DevTools as well, which is arguably better than Chrome DevTools. Yeah. Okay. And another tab you can find instead of elements is this console tab. And this console tab is basically a place where you can enter JavaScript code or run JavaScript commands. It's a JavaScript interpreter, and it runs in the context of the current page. So usually you can just run JavaScript, kind of like do like some fun stuff like console log. But usually you'll also have access to all the JavaScript functions that the page is loaded. And thanks to develop dev tools, it also has autocomplete when you type these functions. But you can also see like information about like errors, like sometimes you can't find files, so it'll log errors here. Or if the JavaScript code fails, you'll also see logging output here. But this console tab will let you basically interact with the JavaScript on the page a little bit closer. If you click on the network tab, you can see all the files that were requested in a particular request to the page. So as we mentioned earlier, the first file that the client browser downloads is the HTML file. And the HTML file has basically all the other links that it needs. So the HTML file defines the script files, JavaScript files, the CSS files, the image files. So you can see here like example.html loads first, and then we get cat.jpg and script.js. And then you can view information when you click on each of these items about things like request headers or response headers. And headers are basically part of the HTTP protocol. They allow you to specify some additional fields when you're making a request to the server. So some fields are like, I want this page in JSON instead of HTML. And if the server supports that, then it will give you JSON instead. Or maybe I want to close the connection now and don't keep it open. Or I want to keep it open, so don't end the TCP connection. And network tools is really useful for like, let's say I do a form submission. You can look at exactly how the form gets submitted, what fields are defined. And you can also like find like file uploads that you sent. And then here is where someone had a question earlier about finding local storage and session storage. So if you click on application, you'll see that there's local storage. Session storage is not highlighted, but session storage is right below local storage. And then you also have cookies. So usually when you're doing web security and you're evaluating a website, you can quickly check cookies to see if it's using cookies, what kind of cookies is it using. Can you decode them and see if you can reveal any information. And you can also look at local storage to see like what application specific state is it storing about you, or maybe like see information about like the things that it's caching. And session storage is sort of rarely used, to be honest. So you'll probably be checking more in cookies and local storage. But the cool thing about DevTools is it lets you click on each of the cookies or each of the local storage items, and you can modify them. And so again, these are all string values. So if I wanted to store something like an image, I need to encode that into a string first. And then I can store that in my local storage or a cookie even. But generally, cookies have a smaller size of data they can store, and local storage has a much bigger size. Like I want to say that each website can have like a megabyte of data stored in local storage. It might be bigger now, and then cookies have a lot less, because it's used just for like very simple op strings. Okay, and then I'll start talking about all this server side and client side stuff, and also we should fix this slide because this is the wrong order on the slide. It should be client side versus server side, but on the client side is where you store cookies, storage, rendering of the HTML to CSS. It's also where you execute JavaScript if it's provided to the browser. And the browser is the one that sends HTTP requests. On the server side, you have backend databases the actual logic, maybe business logic that drives what pages get served to you. For example, it's a logic that prevents you from viewing a page when you aren't logged in. And that server is also responsible for responses. So everything in orange here, or yellow, is what you can change with DevTools. So you can only change, what you're sending to the server and what you are interpreting from the server. But you can't actually change anything on the server with just DevTools. And so in Web Hacking 2, we will go over attacks that you can run against servers to try to make them misbehave and do basically exploit either business logic or just other vulnerabilities that will lead to the server sending you something bad, or in the case of an attacker, good. Does anyone have any questions about this?
I was wondering, like, when you talk about vulnerabilities with servers, is that like with the firmware on like the computers like in the server, or is that like bad things with the code that like end up saying failure on server?
So you talked on 2 points there, and I'll quickly talk about from the perspective of like firmware or the operating system that the server runs on. Normally, in terms of web security, most likely you're not going to be exploiting issues with the server's operating system or firmware. It's usually not firmware, it's usually just going to be like the underlying operating system. This is usually because in the world of web, your server has firewalls and only allows HTTP traffic to that server. So if you wanted to exploit some vulnerability in the operating system that uses a different service, for example, like Windows has the Samba service, or some background service that's running on your operating system. Usually, when you do web security, we're not talking about that kind of vulnerability. If you want to learn about this type of vulnerabilities, you should join Purple Team, because Purple Team will go over explaining those types of services. When we talk about vulnerabilities on the server, usually the server has its own runtime for the web application. So when you build a web application, usually you build the server part and the client part. Or if you want to think about it, front end and back end. So the front end / client side is basically the pretty HTML that gets rendered, and the server backend will have business logic, authentication, and things like that. Does that sort of answer your question? And I will also note that on the back end, maybe you've heard of these technologies before, but PHP is pretty common. It's very old, but it's still the most popular back-end web framework or web programming language. Next.js is a very popular rising back-end / front-end rendering framework, or if you're like working with TypeScript or JavaScript. So that's a little bit confusing because the server is running JavaScript, not the client. The client might run JavaScript, but the server is running JavaScript to do its business logic. And then it gives you HTML and maybe some JavaScript for the client to run. So there's many different web technologies. Some of the first ones are like, you can write web server in C#, or with a lot of old sites, you'll have them written in Java, as Julius mentioned earlier. So yes, there are Java web frameworks, and those will serve you JavaScript files. So
I kind of have something else to talk about on that. So some of the next web hacking presentation that we have will be just how to interact with servers in order to, without having any type of like exploit for the actual operating system or underlying hardware. If you just want to effectively think about what you're inputting into like text boxes, for example, differently, then I would say like. A long time ago, you could do this and it was like actual method, dude, now it's. Kind of not as viable because of modern frameworks kind of having some security. But really, there are kind of two ways you can think about it. One way where they give you something and you kind of just like understand the underlying architecture of their system, and then you type in SQL and kind of like try and get their information versus actually attacking their systems at like the operating system level. So there are multiple different ways, and I feel like as you kind of go through web hacking and understand the systems better, you will be able to exploit really whichever ways you want to, or whichever ways are available.
Thank you. Does anyone else have any questions about client server side security? Okay. So I'm going to update this because I didn't refresh it, but. So. This Thursday, we're going to be running web hacking 2, so that's going to be in DCL 1310. Again, we're going to go more into the server side security, which is one of the more interesting, arguably more interesting than client side security, because inspect elementing and changing the title of a page is not that engaging. But we're going to be going over things like SQL injection. So SQL is a query language that's used to get information from the a database and then render that onto the page. So if you guys have heard of prompt injection, where you have you fake some system prompt and maybe get the system to reveal more information. SQL injection is exactly like prompt injection, except you're exploiting SQL syntax to try to get the database to reveal more information.
Prompt injection is like for chatbots, like ChatGPT or like Snapchat AI. I know David had something on that.
Yeah. If you look at the publication on the page, somebody had David had a post about prompt injection, specifically for Snapchat AI. And we're also going to be talking about cross-site scripting, which is not server-side security, but it is tangentially related to it. That is specifically attacking other browsers. So other users that are using the site, you're trying to attack them rather than attack the server directly. Yeah. And then this Friday, I want to highlight really importantly, because we forgot to announce at the beginning. This is going to be our first CTF. So it's called Seesaw CTF Pulse. Seesaw is Cybersecurity Awareness Week. It's a competition that's run by New York University. And basically, we play this every year. For the past 5-6 years, we've always qualified for finals. So we intend on keeping that tradition alive. It's a limited team size. So basically, every one of you can show up and help us solve challenges. And so you can also see sort of how we play CTFs, learn how to solve challenges. We really encourage basically our more senior CTF players to either have write-ups so you can understand how challenges are solved, or they will lead actually the beginner challenges for you guys. So that way you can test your knowledge. And we will have free pizza. So we plan on meeting in Siebel, this building somewhere. We don't know what room, but we will be here around maybe 6 or 7. The competition actually starts at 4 p.m. So you might see some people online already starting, but we won't be in person until around 6 or 7. And the competition, and this is the case with most CTFs. Most CTFs are 48 hours long. You're not expected, right, to stay the entire time. The 48 hours is purely to cover like a diverse range of time zones. So because CTFs are a very big international thing, not just in the United States. Yeah, and again, all experience levels are welcome to join. And we'll post an announcement again this Friday, or in today and maybe in the coming days about how to join. But generally, you just need to add yourself to the CTF team role in order to see those channels. So I will post information on how to opt in. You can just run a command in Discord. And then next Sunday, after Web Hacking 2, we'll be doing our OSINT meeting. So 1 week from today, we'll talk about gathering intelligence from online, sort of kind of geocacher style, almost. And I don't want you guys to think about it like this, but it's almost like sort of stalking companies to figure out how to break into them. And there's a lot of information you can gather online when you're doing an engagement against for security purposes. Yeah. So I invite everyone to go to ctf.sigpwny.com, enter in this meeting flag, and then we have challenges on web hacking that you can do right now purely with DevTools. So if you find, I'll bring it up so it's easier to see. If you find the challenges page, I recommend you start with InspectMe series. So InspectMe 1, InspectMe 2, all the way to InspectMe 7 and 8, or InspectMe 8. These are sort of the main challenges. There's also Decision Day, which Decision Day was from a previous fall CTF. So if you guys look at Decision Day, maybe you can do a little bit of practice for that as well. And there's a little bit more harder challenges here, such as New Intern, which I believe you guys hopefully will love the site. This is made by Pete. Yeah. But we have some fun themes and some fun challenges there. So yeah, feel free to get started, and we have helpers around to help you solve these questions, these challenges. So just raise your hands and we can help you.
Yeah, so thank you for the web hacking and get to happen. Oh, you have a question? No, you have no question.